we already started the ionic equilibria. Now in that we are starting today, that is the buffer solution. Okay, now say before starting the buffer solution, as you know, what are the weak acid? See here, weak acid, like example is CH3COOH, and then weak base is NH4OH is the example. Now weak acid, we are just dealing with the weak electrolytes. Okay, now weak as you say, what are the strong acids? Strong acids like HCl, H2SO4, HNO3, these are the strong acid. And weak acid, we have taken the example. Here we have taken the example of weak base. Which are the weak strong bases? The strong bases are NaOH, sodium hydroxide, potassium hydroxide. So these are the strong bases. Here we have taken the weak base, that is NH4OH. Okay. Now we have also seen that the types of salts. The salt that is salt of strong acid and strong base, salt of strong acid and weak base, salt of weak acid and strong base, salt of weak acid and weak base. Is it? So that is acid, that is the salt derived from the strong acid and strong base. Is it? Here suppose to this weak acid, a strong base is combined or reacted. Okay, a strong base, suppose a strong base is here NaOH. Suppose here this H and OH react to form the H2O, and the salt forms is CH3COONA. Now this salt is called as salt derived from the weak acid and strong base. Weak acid and strong base, right? So this combination we need here. Now here again, this is the example of weak base. Now here suppose take an example of strong acid. Okay, the example of strong acid is HCl. These two combines, this OH and H reacts to give H2O, and the salt form here is, that is NH4Cl. Now this salt is called as the salt of weak base and strong acid. This we need. Okay, now let us say buffer solution. So this material we need to form the buffer solutions. Now what are the buffer solution? Let us see. Now see, buffer solution is such a solution which resists the drastic change in pH even after the addition of small amount of strong acid or strong base. Okay, or water in it, on dilution also. Okay. Now buffer solution, actually what will happen to any solution, if we add the acid, a strong acid, there is a change in buffers, pH of the solution, right? That means pH decreases. For a particular solution, if we add a base, then what will happen? The pH changes. Is it? Because of the excess OH minus ions, right? That means after the addition of pH, after addition of a base, the pH increases, right? So a solution which does not allow the change, the solution which does not permits the change even after the addition of acid or base, right? So how can you define a buffer solution? Is defined as the solution which resists the drastic change in pH even after the addition, or when a small amount of strong acid or strong base is added and there is no change in pH after the dilution also. So that type of a solution is called as a buffer solution. Now what is acidic? There are two types of the buffer solutions. Okay, see here, types of the buffer solution. There are two types of buffer solutions. One is acidic buffer solution, another is basic buffer solution. Now what is acidic buffer solution? See, initially I said, so this combination, the combination of these two is called as acidic buffer solution. Now how can you define acidic buffer? A solution which contains weak acid and its salt of strong base is called as acidic buffer solution. A solution which contain a weak acid and its salt of strong base is called as acidic buffer. When these two mixed, okay, then that is the formation of a acidic buffer solution takes place. Okay, now see here, that is how the pH can be given, how the pH can be calculated or predicted for acidic buffer. Here the formula is given for this. pH is equals to pKa plus log to the base 10 of that is the salt divided by concentration of salt divided by concentration of acid. Now pH is expressed, pH of acidic buffer is expressed as pH is equals to pKa plus K is acid dissociation constant, pKa plus log to the base 10 of concentration of salt divided by concentration of acid. So pKa is equals to minus log to the base 10 of Ka. Okay, now see here where Ka is the dissociation constant. So this equation is called as Henderson-Hasselbalch equation. Okay, now basic buffer. What is the basic buffer? So what we explained initially, this is the combination is called as basic buffer. Okay, that is a solution which contain weak base and its salt of strong acid is the weak base. This combination forms the weak base solution. Now that is basic buffer solution. Now what is basic buffer solution? A solution containing a weak base and its salt of strong acid, it forms a weak basic buffer solution. Now pOH, okay, the pOH value of the basic buffer solution is expressed as pOH is equals to pKb, where Kb is the base dissociation constant, pKb plus the log to the base 10 of concentration of salt divided by concentration of acid, where pKb is given as minus log to the base 10 of Kb, where Kb is the base dissociation constant. Okay, so this is about the acidic and basic buffer and expression of pH and pOH values. Okay, now see, against the addition of acid or base to these solution, how they works. Okay, now let us see the buffer action. For here example is taken for the acidic buffer. How acidic buffer works against the addition of acid or base to maintain the pH constant. Okay, now see here for acidic buffer, it contains weak acid and its salt of strong bases, that is CH3COOH. Okay, it dissociates very fewly as CH3COO minus and H plus, being it is weak, the dissociation is very negligible. That means the weak acid, that is CH3, undissociated molecule are present in large quantities CH3COOH, being it is weak. But it contains the salt CH3COONA, the salt of weak acid and strong base. So being it is salt, it dissociates completely to give large amount of excess amount of CH3COO minus and Na plus. Okay, now how it resists the change against the addition of strong acid as well as strong base. Now if strong acid is added to this solution, that means we are adding H plus ions, right? So on the addition of H plus ions, the CH3CO minus ions which are present in excess in the solution, they combines with H plus and formation of neutral undissociable CH3COOH molecules takes place, weak acid. So H plus ion is used up and the acid is neutralized by the formation of CH3COOH. So in this way the pH is maintained constant against the addition of strong acid. Now let us say the addition of strong base. Addition of strong base. Now if a strong base is added to this solution, that means we are adding OH minus ions. Okay. The solution, acidic buffer solution contains weak acid molecules. When we add OH minus ions reacts with this acid molecules to form CH3COO minus and H2O molecules, neutral water molecules. In this way, the OH minus ions are used up and the pH is maintained constant. The pH is maintained constant. Okay. So, the addition of acid cannot change the pH. Even addition of the base cannot change in pH of this buffer solution. So, this is all about the acidic buffer. In the same way, you can explain for the basic buffer also. Okay. What is the basic buffer? This is the basic buffer. Here, what are this NH4OH present in large excess, being it is weak, and this dissociates to give Cl minus. See, because of the addition of acid, okay, if we add acid to this basic buffer solution, that means we are adding H plus ion. So undissociable NH4OH molecules used up the acid H plus ions from the strong acid added, right, and formation of NH4 plus and H2. In this way, H plus ions from the acid are used up, right, and the pH is maintained constant. If a base is added, then we are adding OH minus ions, but this contains NH4 plus ions. The NH4 plus ion combines with the externally added base ion, that is ions of the base, OH strong as base. So formation of neutral NH4 molecules takes place, right? Okay. So in this way OH minus ions are used up and the base is neutralized by the basic buffer. So this is the action of the basic buffer towards the addition of acid and bases to maintain the pH constant, right? So this is about the base buffer solution.